Okay, we're going to go through the Chapter 8 intro information. This is all stuff that you have seen in either Algebra 1 and or Algebra 2. So hopefully it shouldn't be too difficult. Your task is to then complete the rest of the problems that kind of go along with the example problems that we're doing. Start off with the midpoint formula for finding halfway in between 2 points. Again, this is an Algebra 1 deal. We're going to have 2 points. We're going to average the x's, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. These are skills that we'll be using throughout Chapter 8, which is going to have to do with conic sections. Conic sections are circles and ellipses and hyperbolas and parabolas. So if we're going to do this one, you're going to take and you're going to average your x's, and you're going to do 2 plus negative 4 over 2, and 5 plus 7 over 2, and I get half of negative 2 is negative 1, and half of 12 is 6, and that was hopefully the easiest thing you've done all year. Distance formula, if we're going to talk about on a coordinate plane, if we were to take and draw a coordinate plane and then say, okay, let's plot the points as to where 3, 7 is. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We got negative 2, 4. 1, 2, 1, 2, 3, 4. And now if we want to make a right triangle, we go here, we go here, and then if we want to find the distance in between them, we would know, well, how far from negative 2, 3, this is 5. I would say this distance down here is 5, and I would say this distance here is going to be 3. And then we would take and use our Pythagorean theorem and say, how do we find that distance? We'd say 5 squared plus 3 squared, right? And then that would be equal to c squared, c being the distance, so I could say c, and I could say, well, we're going to end up square rooting that, so we'd get the square root of 25, the square root of 34. Exact values, the square root of 34 must be 5.8 or so. But remember, what did we really do to get these points? I had negative 2, 4, and I had 3, 7. Where did the 5 come from? I subtracted 3 minus negative 2. I subtracted the x values and squared it. That's where we got the distance on the right triangle. Then I subtracted the y value, 7 minus 4, and I squared it. So my distance formula is really the Pythagorean theorem on a coordinate plane. It's going to be square root of the change in x, x2 minus x1 squared, plus y2 minus y1 squared. It's really just the Pythagorean theorem on the coordinate plane. Subtract the x's, subtract the y's. Some people like to write it as, if you think about the change in x squared plus change in y squared, and then we get a square root, because you can subtract whichever direction you want. If I was doing this problem down here, then substituting it into my formula, I have 5 minus 3 squared. Just got to watch your negatives. Negative 3 minus negative 1 squared, which is, this is going to be 2 squared plus negative 3 plus 1, negative 2 squared, which will be 4 plus 4, which is the square root of 8, which is 2 square root of 2, 2 square root of 2, and I could get the decimal equivalent if I so chose. So distance formula, another thing that you saw in your past. Completing the square. Remember, completing the square, we're looking for, when we're talking about a plus b squared, what do we have? We have a squared plus 2ab plus b squared. And now what we're going to do is we're going to create a perfect square. So this comes from, I'm creating the a squared plus 2ab plus b squared. So if I know this is x and that's x squared, if we're going to create and do a perfect square, we're going to do this. We're going to take x, and it's going to become x. This a becomes a, and then I have a 2 times the first thing times the second thing. So what we're going to do is we're going to cut that in half, right? We cut that in half, and we get 6, and we square it, plus 36. So x squared, we've created a trinomial that is a perfect square. If you think about our formula from what we had in previous factoring and things like that, square the first term, x squared, multiply the two terms together, 6x, double it, 12x, square the second term, plus 36. We'll be completing the square a lot in this chapter, so it is a skill that you need to have. So if I was doing this one down here, I'm going to create a perfect square. My x goes right there. Cut the negative 14, you cut that in half. And that's because of that 2 idea. Cut it in half, minus 7. Square the minus 7 plus 49. Again, we've completed the square. We've made a trinomial square. And now we can factor it into a perfect square. Going to be very useful for what we're going to be doing. I think there's a few more of those. You should complete those after this video is done. Why do we want to do that? One of the reasons is we want to write things in vertex form. Remember, we had a quadratic and standard form was ax squared plus bx plus c. Vertex form, where we have, this is vertex form here. A will tell us if we open up or down, tell us how, if we have a vertical stretch, wider or narrower, and then we have a vertex at h comma k. This is where completing the square can come in handy. I like to do these as moving the 3 to a holding pattern over here. F of x minus 3 equals x squared plus 4x. This is where we're going to complete the square, right here. And I have my x, and I have my 4, I divide it by 2. I say plus 2. I square it. Now this is a big moment. Pay attention. Pay attention. So I square that and I get plus 4. But if I add 4 over here, I got to add 4 over here. So I get f of x, negative 3 plus 4, plus 1. Now I got to subtract that 1 back over. And I get f of x equals x plus 2 squared minus 1. Now we can read the equation. My vertex here is at negative 2, negative 1. And we're set. This one opens up. Value of a is 1 in this one. It's going to get a little bit hairy when we get a value of a little bit different, but we'll show you how to deal with that here in a little bit. I think you have some other vertex form ones that you can handle on your own. Okay, next page. Next page. Very similar to what we just did. Now we're going to run it. This one's going to be the key one. I think the first one, pretty simple. It says we're going to solve. So I'm going to go plus 10, plus 10. First thing I'm going to do is I'm going to get the x terms by themselves. Leave a blank equals 10. This is where I create a perfect square. X divided by 2 plus 3. Square it. Did I hear a 9er in there? I did. And then I got to do a plus 9 over here, because whatever you do to one side of an equation, you got to do the same thing to the other. And we get equals 19. Now we're going to take the square root and the square root, and we get a plus or minus. X plus 3 equals plus or minus the square root of 19 minus 3 minus 3. What's it look like? Negative 3 plus or minus the square root of 19. That would be the exact value. If you wanted a decimal equivalent, my minus would be approximately negative 7.36. My plus, grab your calculator, would be 1.36. There's my rounded values, so pay attention. Do they want a exact value or rounded value? Here we get it right here. What happens if we take the square root of a negative? You're going to have an I, aren't you? Not like the I in your head, but an I for your answer. Okay, I said this was going to be the big dog right here, so let's make sure that we're all paying attention and we're all in the right spot, because this is the one that has a little bit of trick to it. You got to pay attention. First thing you're going to do is minus 10 minus 10, because again, we are getting the x terms by themselves. Now, we can't complete the square until we get the x squared term to be all alone. So the examples we've done so far, the value of a out in front has been 1. Now I need to factor out a negative 3, which turns it into x squared plus 2x blank equals negative 10 blank. This is the big moment. Big moment. So I have a negative 3 coming along for the ride. I get an x. I cut that in half. I go plus 1. And I have a squared. So I cut the 2 in half and get plus 1. And then in here becomes I square it plus 1. But what did I really add or subtract to the left side of this entire equation? We must remember that this negative 3 was factored out. If I was to put this negative 3 back in, I would distribute and get minus 3x squared minus 6x minus 3. Over here goes minus 3. That's very important that you understand that this minus 3 is in this whole thing, because if you think about where this came from here, but this negative 3 is still being multiplied. So in order to put this back together properly, we have to take into account that that minus 3 is multiplied there. And I get minus 13. And now we will divide by negative 3, divide by negative 3. X plus 1 is equal to 13 over 3. Whoops, there's a square there. Square root, plus or minus. X plus 1 equals plus or minus the square root of 13 over the square root of 3, which means I need to multiply the top and the bottom by the square root of 3. And I need to subtract that 1 and subtract that 1. And we get x equals plus or minus the square root of 39 over 3 minus 1. Where did the 39 over 3 come from? Remember, square root of 13 over the square root of 3, multiply. It's not letting me write over there. Try it again. The square root of 13 over the square root of 3. Multiply the top and the bottom by the square root of 3. You get your square root of 39 over 3. So my answer, I know you probably can't see it on the bottom there. Let's write the answer. We'll write it in big fat red. X equals plus or minus the square root of 30. Whoa, I would want the 1 first. Sorry. 1. Whoa, terrible. I'm going to start again. X equals negative 1 plus or minus the square root of 39 over 3. What if you wanted a decimal equivalent? Could you type that into your calculator with the plus and with the minus? You're darn right you could. Okay, find this problem. It has to do with the circle stuff. Now, if you remember back to our chapter 4 and chapter 5, some of you are trying to forget about it. You remember that we had on my unit circle with a radius of r, and then we had x comma y. So any point on a circle can be written as x squared plus y squared equals r squared, but that's when it's centered at the origin. So you have that formula right there. And then in the unit circle, we just turn this into a 1. Well, that's not going to be the case for all these other circles. And then we have x minus h squared plus y minus k squared equals r squared. Well, how are we going to go from something that is in standard form like this into something that is going to be in, this is called vertex form or the center form of the circle. So the first thing I'm going to do is I'm going to group my x's. So I have x squared plus 4x, leave a blank because we're going to complete the square, and then group your y's, plus y squared minus 8y, leave a blank, chase that 16 to the other side. So I move this over. All I did was group my x's and group my y's because my next step is going to be to turn this into my x minus h squared and turn this into my y minus k squared. And we're going to do that by cut it in half, plus 2, square it, plus 4. Whatever you do to one side of an equation, you got to do the same thing to the other. Right here, negative 8. I'm going to have a y, cut it in half, minus 4, square it, plus 16, equals 16 plus 4 plus 16, 36. This is the equation of the circle. Now we're going to read the equation of the circle, and its center will be at negative 2, positive 4, and its radius is the square root of 36, or 6. You should be able to complete the rest of the intro packet at this point. I will put the notes on Schoology as well so you can check your answers. Don't just copy the answers. That will do nothing for you other than waste pencil lead and your time.